So domain and range for continuous relations. We've talked about domain and range, and we're going to look at it here on continuous relations on graphs. And we'll start out with a quick reminder here. So we're going to use inequality signs, and just a quick review here. So less than equal to signs, if you'll remember, are going to kind of open out to the right. And less than equal to means you'll have the line underneath. Okay, so less than equal to sign looking like that. And then the opposite, of course, greater than equal to, opening to the left side here, equal to, meaning you have the line underneath. So you include whatever value we're looking for is included in the less than equal to or the greater than equal to. So just reviewing those signs real quick because we're going to use them. And let's get started. Let's look at the first graph that we have. This basically looks like a graph of a circle or an oval here. And we're going to find the domain and the range, and then we're going to decide if this is really a function or not. So what we're going to look at, this circle, obviously, it crosses this axis at a bunch of different points here. We're going to look at the domain first. So if you'll recall, domain is your input or your x values, okay? And that's your values along the x-axis. And remember, your x-axis moves horizontally, kind of left and right. And I'll draw it in green here on our graph. And we've got that circle going across. It actually hits the x-axis at 2 points, you'll see. So let's get those 2 points, and then we'll go ahead and we'll go for the domain. We'll write it in. So the 2 points it seems to go across, we've got one spot right here. We'll kind of draw in that it seems to be going across. And then over on the positive side, going kind of right there. So let's figure out what numbers we're going across at, and then we can turn this into a domain and write it out. If we start on the left side, we start to the furthest to the left over here. 0, of course, remember 0, 0 is right in the middle of your x and y axis. So this line is going across right here. It looks like at -4. 1, 2, 3, 4. So -4 is a spot where this is going across on the left side on your domain, your x-axis. And then on the right side, it looks like if we start at origin right over here, 0, 0, we're going 1, 2, 3 at +3. Okay, so now we can go ahead and we can turn this into a function. We can use those inequality signs and we can write it. So we're going to say this. We're going to use x. X is our domain value here, x. Now we're going to say we start with -4. So x is actually any of the values that are in between -4 and +3. So we would write that as this. -4 is basically less than equal to x, and then x is also anything that is less than equal to a +3. And what that tells us is x is basically any of these values. I had it in green, but any of these values in between where the -4 and the 3 go across as a domain on the domain side on the x, okay? So let's look at the range then. So remember, the range is your y, your output values, okay? I think I can make a neater y there. There we go. And it's vertical on the graph, remember. That's your up and down axis as you go, and it's this one that I'm putting in yellow. So where is the circle crossing these, okay? And you kind of see where we're going with this. Well, on the negative side, we're crossing right here. And that is, if we start at origin again, that's it, -1, 2, 3. So -3 right there, negative signs in. And then on the positive side, it's going across right here, back to origin 1, 2 at +3. So let's do what we did like the domain, but let's write in the range. And we're going to do this, though, instead of using an x, we're going to use a y, because that is our range value there, y. And we're going to say, essentially, that the range is any of the values in between -3, so less than equal to -3, and y is also going to be, or y would be greater than equal to -3, and then less than equal to here, +3. So this is how we write here domain and range when we have these, like we said in the title, when we have our continuous relations right over here, okay? Now, is this a function or is this not a function? So let's look at this real quick. We talked about this yesterday. We talked about the vertical line test. And I'm going to shorten that down to, you might see it shortened down to VLT, vertical line test. So, I don't know, let's run the vertical line test real quick. What if I switch over here to red and we run through here? Remember, if we cross it more than 1 point on our graph here, if we hit it more than 1 point, it's not a function. So it looks like I'm going up, I hit this oval right here, and then I keep going and I run into it right there again. So this is actually not a function. Is this a function? No. And because really there's no repeating x values is what we could say, but we're going to say does not pass, and I'll just put VLT for vertical line test, okay? And I apologize, kind of jumbled that in, but there you go, does not pass vertical line test, all right? So let's try another one. All right, we got this one, this straight line going up. Now, it's straight, we got a line basically, but it's got arrows on it. So these arrows are kind of showing us that this thing is continuing all the way to the right, going up or down to the left, however we want to say that, all the way through. It continues, it does not stop. So that's going to kind of change up the way we have this. So when we look at first the domain, so let's look at the domain first, and remember that's our x values going vertically, of course, or horizontally. I just misspoke, going horizontally, of course. We're looking at this, and really that line, because it's going up and to the right and down and the left, and it continues, it really represents, it doesn't stop anywhere, it really represents any value along that x-axis. It continues to go kind of infinitely. So what we could say here is that for a domain, instead of using our inequality signs and finding a number, because it continues, we can say that it's represented, I guess we can say all real numbers. All real numbers. And if you remember, real numbers are basically any value, if I can write, any value on the number line. So all real numbers, kind of scratch that in there. And there's a symbol for all real numbers. So what it is if you write an R like that, and then you put kind of a line, kind of a double line R, that can show all real numbers, okay? And I didn't write that super neat. But let's look at the range then. So the range then, like we said, y values, vertical, got that right this time. So again, coming up here, vertical values, going like this. So again, what are we looking at? A line that continues, and if it continues both going up and through the whole graph that we have here, then this is showing us again that it could represent any of the values on the number line. So here we are again at all real numbers. All real numbers. And we could use that symbol too. I'll put it in there. But right now I'm going to write it in. All real numbers. Again, that's that R. Kind of put another line through it. All real numbers. So is this a function? So let's run the vertical line test real quick. I can run it in red real fast. And it seems like it's going to be, because as I go up, it's really only hitting this line that's gone across with the arrows. It's really only hitting this in one place, not hitting this in another place. So yes, this is a function. Yes, this is a function. It passes the vertical line test, the VLT, and doesn't have any repeating x values over here, okay? Alright, so let's try this. Let's look at this over here. Got another example or two. Kind of looks like a V that's been graphed here. Arrow going up to the left and the right. It does continue though, okay? So again, let's get into the habit. We'll speed it up a little bit. So x values, domain here. We're looking at our horizontal x values. And how is this thing going? Well, this is going to be kind of similar to the last one, because this arrow seems to be kind of going up and to the right and to the left, and it continues because it's got the arrow at the end. It's really representing any of the numbers along the x-axis, right there. So this again is going to be another place where we're going to have an all real numbers answer that we can jot in. So I can put that real quick. All real. Don't like that bar. All real numbers. And then I'll put that symbol too. All real numbers are with the line through it. Here we go. And then let's look at the range. So we had the x-axis for the domain. Range, of course, y values, vertical. Coming up here. So this is a little different. It doesn't continue down with the arrows. You'll see that it stops right there. It doesn't continue down. We actually stop at a coordinate. Well, where is that stopping right over there? It looks like it stops right at -2, and on the y-axis as our range, okay? So we can actually write this in. What is y? Y is actually equal, if you look at -2, y basically goes from -2, and it goes up anywhere here. Y -2 goes up anywhere from there. So it's basically any of the values that are greater than -2. It does not drop below -2. So as we write in our range, we can say y, sorry for switching the screen, is any value that is greater than or equal to -2. Greater than or equal to -2. That's because it stops at -2. But it does go up to any of the values that are greater. So is this a function? And I think y'all are putting these together pretty quick probably. Yeah, it seems to be, because vertical line test goes up. This is only going to hit this one time. We're only going to go through this one time. So yes, this passes the vertical line test, the VLT. And we look good there. Let's try one more, just because you'll see a lot of graphs that are like this. And this is actually pretty similar, okay? So pretty similar here. Again, domain, x, horizontal axis going across over here. And this is kind of similar to that last one. It looks like the lines could really represent anything along the x-axis, because these lines would continue to the right or the left with the arrow. So the domain again here is going to be one of these all real numbers. All real numbers. I'll write it underneath this time. I'm running out of space. And y'all know the symbol. We've been putting it in R with that line through it. I don't like that one that much. There we go. And then the range. So kind of similar here. The range going down seems to stop again. If we look at the y-axis, we seem to stop right there. It's not going below that point. What point is that? Just happens to be that it's -2 again, coincidence with the last one. But this one's -2 also. So y again is going to be any value that is greater than or equal to -2. And then easy part, is this a function or not? Yeah, it's a function. You go up right over here, it's going to only hit this one time as we go through. So yes, and yes, it passes the vertical line test. All right, passes the vertical line test. So awesome job in the notes, reviewing here domain and range, and then working on domain and range for continuous relations.